Hey, hello. Today, let's look at the leetcode 120 triangle. So in this problem, we are given a triangle array, and this is a array inside the array like this, two-dimensional array, and we need to return the minimum path sum from top to bottom, right? So this is the requirements, and for each of the step, we can only move to the adjacent number of the row below. That means if we have a 2 here, we are only allowed to move to 3 or 4 if 2 is in this path we're looking for. And for 1, then it's a 4 and 5. 2 cannot move to 5 because that's not the adjacent according to this. It has to be I or I plus. So this is actually I plus 1. So this is the restriction here. Here is one example. So the path we choose is 1, 5, 3, 2, and all plus together that equals to 11. So as you can see, 1 and 5 they are adjacent, and 3 and 5 are adjacent, and 2 and 3 they are adjacent. So this is like a zigzagging in this triangle. Our goal is to implement the algorithm that can return us always this path that gave us the minimum sum. So this is the goal here. Let's jump to the content to see how we can solve this using the dynamic programming method. Okay, now let's look at how we can solve this problem with DP. So when we consider to solve a problem with DP, we always need to find the global solution, how to construct it from the subproblem, right? So in this case, it's actually what we want to have is the uh, total path here, like from top to bottom, and we want to know the minimum, right? So if we think about how to divide this problem into subproblem, what we can consider is that we could actually have divide this triangle into two parts, right? So 2 will stay the same. That's the final level or the top level here. If we could find the minimum path here, that gave us the minimum value on the left hand side, and then we could also have the minimum from the right hand side. If we could actually find this thing, assume we know this thing, then in order to for us to have the global solution, we simply need to pick up the minimum value from the left and right, then use the minimum value to plus 2. That will be our global final solution. So this is the way how we can construct the global solution from the subproblem. So we simply divide left and right to two subproblem, and we try to figure it out. So in this case, if this is the subproblem here now, right? So then what we can do is further divide it. We can actually divide these as a subproblem and these as a subproblem. Then we will solve that. And same thing apply to these. So if we have these, if we consider this as a subproblem, we can further divide this into this kind of a subproblem, 4 and 1. So this actually gave us the indication that when we have only one element in the subproblem, then we don't have to compare anything. The element itself is our optimal solution. So in this case, if we want to know what's the optimal solution for this subtree, we simply pick up the smallest one here. Here is 1, and then plus 6, that's 7. So that will be the solution for this subtree. And so with this idea, we can actually write this formula. That means the lower level elements I and I plus 1, because these are the adjacent value we are allowed to use, right? So we pick up the minimum from that. So that's corresponding to this one, and this one we pick up the minimum that equals to 1 here. So this minimum will return 1 in our this sub problem case. And then after that, we go one level up to find the original value in the triangle, right? So this pay attention to the level here. This was in the L plus 1, but here is L. So we move one level up to find the value here, and then use this value, 6 plus 1, then that gave us the 7, which is the optimal solution for this subproblem. We simply repeat to do that for this one, then one level up for that, and then for the final one. So this is the way how we construct this problem to get our final solution. So now we know how to solve this problem with the dynamic programming, how to divide our subproblem. Let's look at our solution. Let's look at the code, right? So we're given this tree, and so in order for us to start from bottom, we actually need to know how many level we have here. That's L. And also we will start from the bottom level, so we need to know how many elements is there in the last layer, right? So this is actually these are two lines here. We first get the number of level, and then got the length of the last layer. And after that, we construct our DP table. The DP table in the very beginning, it will look like this. We put everything there as a 0. It only shares the same shape as the origin triangle here, but this is our DP table. It has the same shape, but all the elements is 0. So that's what we do here with this line. And then after that, we simply copy this last level here to this DP table, because this is the last level. We don't the value inside it is our optimal solution for them. So this we don't have to do anything. We can simply copy it over here. So let me rewrite this you can see it better. 4183. So we copied here. Then after that, we start to construct the tree. So this is actually what we do with this two level loop. So the outer level is to go through all the level from bottom to up. The inner loop is actually try to go through the elements on each level. So here we have the formula to construct this one. So basically, from this one, we simply do pick up the minimum 1 here, and then pick up 6 from here. Then we put 7 here as our solution. Then same continues until we got final the top one 11, and this top is actually corresponding to dp00. So that's why after we finish this loop, we got our value we want. We simply return the top. The top elements is what we want with the final value. And this is the way how we do this using the dynamic programming to solve this triangle problem. Thank you for watching, and see you next time.